Database security isn't just about passwords. Have you heard of row-level security? Here's why it matters. With data breaches and leaks becoming more common, securing your database goes beyond the basic authentication. Supabase, built on PostgreSQL, offers a powerful security feature called row-level security, RLS, to control access at a granular level. But how does it work and why should you use it? Let's break it down. Row-level security is a PostgreSQL feature, first, that allows you to enforce fine-grained access control at the row level. Instead of relying on the broad table-level permissions, RLS ensures that users can only access specific rows that they are authorized to view or modify. So how does RLS work in Supabase? First, you create security policies that determine which users can access which rows based on conditions. So there are different types of users. You can have unknown users, you can have authenticated users, that all types. So you first have to create the security policies. Then the beauty is that in Supabase, these policies are automatically implemented and automatically restrict access without requiring any complex application side logic. The policies are applied to the tables automatically. And lastly, it enforces security at the database level. Because the database enforces RLS, unauthorized queries are blocked before they even reach your backend. Okay. For example, if you have a messages table in a chat app, you can create a policy that allows users to see only the messages they sent or received. Let's take some real-world examples. So if you're building a SaaS application where different companies share the same database, RLS can ensure that each company's data is isolated like this. You create a policy that uses a select command, and then you specify using the company ID and using auth.jwt. Another scenario is in an human resource application where employees should only be able to access their own records while HR managers can access all the records. So you can have two types of policies of the select command. So you can have one policy where employees can only view their own records, and then you can have another policy where only HR managers can view all those records. So those are two roles. You can have a role for employees, and then you can have a role specifically for HR manager. You can also set different permissions based on user roles stored in a roles table. So you can create a policy that allows admins to update any record, and so that will be an update command, right? So you just define a role called admin, and through that anyone who authenticates themselves as an admin, they'll be able to update specific rows in the users table in this case. While RLS is powerful, incorrect configurations can lead to security gaps. Here are common mistakes as developers we can make. First, we can, by default, new tables in Supabase have RLS disabled, so you need to enable it by yourself manually. You can do this easily on the table editor in the Supabase dashboard, and just when you're editing your table, there's a section where you just check and enable RLS. Or if you want to use the SQL editor, you can run the SQL query that alters the table users and enables the row level security, like so. Another mistake that we do is having a poorly written policy, which might unintentionally allow unauthorized access if you do not specify your policy in detail in terms of roles, in terms of what they can do, because we have like 4 commands. We have the select, update, delete, and insert. Yes, you need to specify these 4 commands And if you have different roles, you have to specify for the different roles if they have different permissions. So if you create a poorly written policy, you may accidentally allow unauthorized access. So you always need to test your policies with the different users and roles before deploying. Another thing will be some developers you assume API based authentication is enough, which is not. However, without RLS, a malicious actor can gain access to your API and query the entire table very easily. I know we have the unknown user, which is very good for time for testing and all that. But if it's possible, once you've done like maybe your prototype or created a simple MVP just to showcase, it's important to use these other specific roles and permissions to be able to make sure that the right people are querying your database. And another one will be, well, RLS supports complex conditions. As much as we are going into detail and making sure we're not creating a poor written policy, it's also dangerous to make it too complex. Keeping policies simple make them easier to manage and debug. So don't complicate it to the highest beta. If you overcomplicate it, now it becomes even more difficult to know or to identify even if there are any gaps involved. Just make it simple, make it easier to manage, let it do the bare minimum of what it should do in specifics. Okay, to make the most of RLS, we can follow some best practices. First one is we grant users only the minimum permissions they need to perform their tasks, and that we can specify in our policy. So the least privilege that they can have. Another one is Supabase allows you to use JWT claims in policies to provide that dynamic access control. Also, instead of writing individual policies for each user, you can group them based on roles and responsibilities. So you can group your policies for scalability purposes. And lastly, periodically, it's important to review your RLS policies just to ensure they are still relevant and secure. Supabase's row-level security is a game changer for securing your database at the most granular level. It can be tricky, mostly when you're starting and you bump into bugs, or sometimes you find when you create in the front level when you're executing or calling an API endpoint to the Supabase, to the database, you receive no response. Most cases you find either you haven't enabled if you have enabled RLS, but you haven't created policies based on whatever you are actually executing from the API endpoint. So it will return a blank. Okay, so those are some of the common issues that you get when it comes to RLS. By enforcing security directly at the database level, you can reduce the risk of unauthorized data access. Security is the most crucial and the most important thing in our field, and in mobile app development, it cannot be taken lightly or cannot be simplified. It has to be taken into consideration as it deserves. And Supabase, through the row level security, and also there's a column level security, but row level security goes to the granular level where it gives permission for who can actually access a specific row. So it simplifies your security model or the security model of your application by implementing that, other than the other authentication phases that are important in the front level. Okay, but this one is mainly involving the database level because that's where the data is stored. Have you implemented RLS in your Supabase app? Let me know your thoughts in the comments, and if you need help seeing RLS in action, I have been working on a tutorial on Supabase and Flutter, and I shared the first part end of last year, which is long overdue. Sorry about that. Thanks to the incredible feedback from many of you and the generous support of those who want to help me continue creating, I'm excited to announce an upcoming membership right here. This will allow me to provide full and finished in-depth tutorials from the start every month based on the topics you want us to learn. Your support means the world to me, and I can't wait to build this with you. Stay tuned, it's launching this month, and we'll still have plenty of free content for everyone right here.